I'm Steve Rintoul. I'm an oceanographer who studies the Southern Ocean, the vast ocean that surrounds the Antarctic continent. I'm studying how the ocean changes and what the changes in the Southern Ocean might mean for the Antarctic ice sheet. The Southern Ocean has a really profound role in the Earth's climate. And the reason for that is because of the unique ocean currents in the Southern Ocean. So we're studying those ocean currents and how they affect today's climate, but even more important is how they might change in the future. Because if the Southern Ocean currents change so that the Southern Ocean absorbs less heat and carbon dioxide, for example, that will speed up the rate of climate change. Traditionally, we always thought that the part of Antarctica south of the Pacific Ocean, West Antarctica, was vulnerable to change, and it waxed and waned and caused sea levels to rise and fall in the past, but that East Antarctica, where most of the ice is, was pretty stable. Well, we've had some new observations from satellite measurements that showed that some East Antarctic glaciers were thinning almost as rapidly as the glaciers in West Antarctica, and we didn't know why. So this summer we set out on the Australian icebreaker, the Aurora Australis, to go visit one particular glacier called the Totten Glacier and try to see whether the ocean had any role in the thinning of that glacier. The Totten Glacier is of particular interest to us because that one glacier alone holds the equivalent of about 3.9 meters of global sea level rise. That's about half of a Greenland in this one glacier in East Antarctica. We were the first ship that managed to get to the glacier. It's usually surrounded by really dense, heavy sea ice, so it's hard to get there. We found evidence that warm water was reaching the glacier, and that provides this really strong evidence that the ocean is driving thinning of this major glacier system in East Antarctica. And the implications for the future are that East Antarctica is not as immune to what happens in the ocean as we thought. And to figure out how sea levels are going to rise in the future, we need to take East Antarctica into account as well as West Antarctica. The Antarctic can be a tough place to work, and in particular, up against the Antarctic continent, sea ice is often a problem for us. So moorings that we deployed a year ago in nice open water were covered by heavy sea ice by the time we got back. So we had to invent an alternative way to get them back. One of the instruments was picked up by a vast iceberg 500 meters thick, dragged along the seafloor for 4 miles or so, and we were very lucky to find it in its new position. A few of the instruments didn't talk to us, and for those we had to form a sort of lasso out of wire and grappling hooks that we made up on the ship and dangle that over the ship and see if we could hook onto the instrument. And that worked successfully, so we got an instrument back that had been sitting there for 4 years, covered by sea ice. We finally had a chance to get it, and it worked. Climate, for me, is an amazing thing to study because the ocean, the atmosphere, the ice, the land surface, vegetation, it's all working together to determine the climate we have now. And it's important. Our human activities are giving the climate system a massive kick, and the consequences of that will be widespread, and we need to understand what they are so that we can avoid the worst of it and adapt to those changes that we can't avoid.